What if we told you that the future of, well, robotics, smart factories, even a lot of the latest tech innovations, that they rely really heavily on something you've probably never even thought about?
Right?
We're talking about these tiny, really crucial components, the ones that allow for precision movement. They make everything possible, from automated assembly lines to advanced medical
Yeah,
devices.
the hidden workhorses.
Welcome to the deep dive. This is where we extract the most important nuggets of knowledge from the sources you share with us.
Hmm.
And today, we're diving deep into the global linear motion ball bearing market. Now, okay, the name sounds super technical, I get it.
It does a bit.
But these components, they're honestly the unsung engineering marvels of modern industry.
Yeah.
Just picture like the incredibly smooth, precise glide of a robotic arm on an assembly line,
Yeah,
or the frictionless movement of a 3D printer's head back and forth.
exactly.
Linear motion ball bearings are those precise little pieces making these exact, repeatable movements possible, always along a straight line.
That's the key, the linear part.
So our mission today is to unpack a recent market analysis. It's from Cognitive Market Research. We want to understand the current performance, sure, but also the future projections.
And the regional differences.
Exactly. The regional dynamics of this, well, surprisingly vital global market. And maybe most importantly, we'll connect back to you, showing why its sort of quiet growth is actually driving some of the most visible tech advancements around us.
Right.
Okay, so let's unpack this. Let's think about how these kind of hidden components drive the visible tech we see every day.
It really is fascinating how something so fundamental can, fly under the radar. But its growth trajectory, it's undeniably impressive.
Okay.
So get this. Back in 2021, the global linear motion ball bearing market generated revenue of over $8.3 billion.
8.3 billion. Wow, that's already a staggering figure for parts most people haven't heard of, but the source suggests that's just the beginning.
Oh, absolutely. This isn't just about small incremental growth. The market is projected to surge. We're talking over $10.2 billion by 2025.
Okay, so a big jump in just a few years.
A huge jump.
Hmm.
And if you look further out, say to 2033, we're looking at an impressive $15.5 billion.
15.5 billion.
Yeah. And this reflects a pretty robust compound annual growth rate, the CAGR, about 5.28% over that whole forecast period.
Okay.
What's really significant here is that we're looking at a market that's expected to almost double in size in, just over a decade.
That's incredible growth for something so specific. So if this seemingly obscure market is set to nearly double, the big question is, where is this explosive growth really happening?
Right.
Let's take that regional deep dive, because the report offers some really compelling insights into the, let's say, different engines of this expansion. Where should we start? North America.
Yeah, let's start there. North America is, a mature market, but still highly innovative. It's definitely contributing. It generated over $2.2 billion back in 2021.
Okay.
And that's projected to grow to almost $3.9 billion by 2033.
Still significant growth, then.
Oh, yeah. And the United States, well, predictably, it's the dominant force within North America, driving a lot of that upward trend.
So what's behind North America's consistent growth? Are there specific industries or trends that really stand out there?
What's interesting here is that while the growth rate is steady, maybe not explosive like some other regions we'll get to, it reflects this deepening reliance on advanced automation and high-tech manufacturing.
Ah, right.
Think about the increasing precision needed in sectors like aerospace, medical devices, even specialized automotive manufacturing.
Right, things needing super high accuracy.
Exactly. Those industries demand the absolute highest level of accuracy, making these linear motion ball bearings totally critical.
Yeah.
And even Canada and Mexico, they're showing solid, consistent contributions. Mexico, for instance, has a CAGR of nearly 5%.
Yeah.
That tells you there's strong, ongoing industrial evolution happening across the whole continent.
Okay, that makes sense. Now let's shift our gaze across the Atlantic. Europe, what does the landscape look like there for these essential components?
Europe also shows strong, steady growth. It's moving from over $1.7 billion in 2021 to an expected $3 billion by 2033.
3 billion, also pretty solid.
Definitely. And Germany, well, as is often the case in these industrial markets, Germany is leading the charge. It's got a particularly impressive CGR, over 5.4%.
Okay, Germany leading the way. What makes Germany such a strong performer in this specific market? Is it just their overall manufacturing strength?
Well, if we connect this to the bigger picture, Germany's growth is very much tied to its Industry 4.0 initiatives. You hear that term a lot.
Right, Industry 4.0, smart factories, automation.
Precisely. focusing on smart factories, highly automated production lines, sophisticated robotics, and that kind of advanced manufacturing inherently requires precise movement at every single stage.
Which directly fuels demand for these bearings.
Directly, yeah.
Hmm.
Now, while some other countries like, say, Russia and Luxembourg, they show slightly more modest growth rates, the overall European picture is still one of continuous robust expansion. It's driven by upgrading existing infrastructure and really adopting those next-gen manufacturing techniques. The UK is also showing solid growth, projected to hit over $400 million by 2033.
Okay. Now, here's where it gets really interesting based on what you hinted at earlier. When we talk about the undisputed powerhouse, the fastest growing market globally, all eyes turn to the Asia-Pacific region, right?
That's absolutely right.
Tell us why it's such an outlier.
Asia-Pacific is truly the growth engine here. It's experiencing an almost exponential surge, it feels like. It expanded from over $3.4 billion in 2021,
Which was already the biggest region then.
already the biggest, yeah, to a staggering projection of over $6.7 billion by 2033.
Wow, nearly 7 billion.
And that's driven by the highest regional CGR of all, nearly 5.9%. What really stands out, though, is that this one region alone is set to account for almost half of the entire global market by the end of the forecast period.
That's just a phenomenal leap. And within Asia-Pacific, which economies are really pushing that scale of growth?
Well, China, as you'd probably expect, is the largest single contributor. It's projected to more than double its market value to over $2 billion by 2033. And that's with a really robust annual growth rate over 6%.
Okay, China's huge. But you mentioned fastest growth rate.
Right, but the real headline, if you're looking at pure growth speed, is India.
India. Interesting.
Yeah, India boasts the highest regional CGR. Get this, an incredible 6.671%.
Whoa, over 6.5% annually.
This suggests a truly significant surge in industrial activity there. It's likely tied to its ambitious domestic manufacturing initiatives like Make in India.
Makes sense.
And we also see really high growth rates in places like Singapore, over 6% CGR, and across Southeast Asia generally, which is collectively growing at over 6.4%. It reflects widespread, rapid industrialization and technological adoption across the entire region.
So it's not just one or two countries.
Not at all. This isn't just about building more factories. It's about massive investments in high-tech sectors. Think electric vehicle production, advanced electronics manufacturing, both industries that are incredibly reliant on the kind of precision these bearings enable.
Got it. So Asia-Pacific is clearly the dominant force and the fastest riser. All right, let's broaden our view again. What about the emerging markets? South America, the Middle East, Africa. Are we seeing similar patterns there, maybe on a smaller scale? Industrialization fueling demand?
Absolutely. The pattern holds. South America's market, for instance, is projected to nearly double from its 2021 level. It's expected to hit over $1 billion by 2033.
Over $1 billion there, too.
Yeah, with a healthy CGR around 5.5%.
Yeah.
Brazil is a key contributor there, naturally. But actually, Argentina is showing a particularly strong growth rate, over 6.1%
Argentina.
PGR.
Okay, interesting.
Yeah. And similarly, the Middle East market is also set to nearly double its value. You see strong performances from the UAE and Turkey, both seeing PGRs above 5.9%. Saudi Arabia is also projected to reach about $136 million by 2033.
So strong growth across the board there as well. And what about the African continent?
Africa, well, it's starting from a smaller base, obviously, but it's also demonstrating significant momentum. Revenues are climbing from roughly $184 million in 2021 to over $350 million projected for 2033.
Still almost doubling.
Still almost doubling, yeah. South Africa is leading the charge there, with a consistent growth rate of over 5.2%. So across all these regions, what we're really witnessing is this foundational shift. Economies are investing heavily in modernizing their industrial capabilities.
And that inherently increases the demand for precision components like these bearings.
Exactly. It's almost a prerequisite for that kind of modernization.
Okay. So if we try to synthesize all these findings, what we're seeing is just this consistent, sustained, and truly global expansion of the linear motion ball bearing market. It's everywhere.
It really is.
And you, the listener, might still be thinking, okay, lots of numbers, but why should I really care about tiny ball bearings?
Right. And if we connect this to the bigger picture, it's because these components are absolutely fundamental. They're fundamental to the advancements in manufacturing, precision technology, and, importantly, the automated systems that are increasingly shaping our world.
Okay.
The core drivers of this growth. They're exactly what you read about or see in the news every single day. That relentless march of industrial automation,
Hmm.
a proliferation of robotics everywhere, and the growing demand for smart machinery. These bearings, they're the hidden mechanics behind how goods get produced, the intricate movements of robots doing complex tasks, and the silent enablers of next-gen machinery.
Yeah.
Everything from, say, your phone's camera assembly to the automated warehouse robots picking your orders.
Exactly. Just take a second and think about how many everyday items and services implicitly rely on this kind of precision engineering.
It's almost countless when you start thinking.
Right. Whether it's the seamless manufacturing of your smart devices or the lightning fast automated packaging you see in logistics centers, or even highly sophisticated medical equipment like MRI machines or surgical robots. These tiny bearings are right there at the heart of it.
Hmm.
So this isn't just about factory floors anymore. It's about the accelerating efficiency and capability of, well, virtually everything we interact with.
Well put.
So to summarize then, this deep dive reveals a remarkably robust and frankly rapidly expanding global market for linear motion ball bearings. We've seen incredible consistent growth across every single region. Asia Pacific clearly leading as the fastest growing powerhouse, mainly due to that industrial surge, but also strong, steady gains across North America, Europe, South America, the Middle East, and Africa.
A truly global trend.
And this growth, it isn't just a collection of numbers on a page, it's a really clear indicator of this profound global shift towards a more automated, more precise, and definitely more technologically advanced future.
Absolutely. And building on those foundational drivers we talked about, industrial automation, robotics, smart machinery, we're kind of left with a compelling question for you to think about.
Okay.
Given the absolutely foundational role of these precise components, what new breakthroughs might this continued growth enable? Breakthroughs in automated systems, advanced manufacturing, maybe even entirely new industries we haven't conceived of yet, all happening in the coming decade.
That's a great question. How might these seemingly small, almost invisible mechanical pieces continue to quietly drive the next big wave of technological transformation? How might they impact our daily lives in ways we're only just beginning to imagine?
Something to ponder.
Definitely something to ponder. And of course, for even deeper insights, maybe some strategic recommendations into this quietly powerful market, you can always explore the full report. That was from Cognitive Market Research.
Welcome to the Deep Dive. Today, we're pulling back the curtain on something you probably interact with every single day but maybe never really see. We're talking about the incredibly precise, often overlooked linear motion ball bearing. Our mission here is to show you how these crucial components are, well, quietly powering the future of automation and advanced machinery. We've dug into the latest research to pull out the really impactful stuff.
Yeah, and just to set the stage a little, these linear motion ball bearings, they're essentially components that allow things to move back and forth really accurately, very smoothly, with minimal friction.
Minimal friction, that's key.
Absolutely. They're kind of the unsung heroes of precision movement in machinery.
Right. You know, it's easy to just gloss over these tiny parts,
Yeah.
but our research really showed how fundamental they are, especially with this global automation boom happening. So what's really driving the demand? Why are these tiny but mighty components so critical right now?
Well, it's striking just how deep their roots go into the rapid rise of automation. Think about manufacturing, industrial processes, like automotive.
Electronics?
Exactly. Automotive, electronics, even packaging. These sectors are pouring money into advanced machinery, CNC systems, or robotic arms, 3D printers.
And they all need that smooth movement.
Every single one. They rely on these bearings for that precise, nearly frictionless motion. It's not just about going fast anymore. It's about micro precision, but doing it at scale.
Yeah, exactly. And it's more than just volume production, isn't it?
Great.
We're also seeing this push for systems needing incredibly high speed with almost zero friction. Like, I'm thinking semiconductor manufacturing, maybe optical inspection tools.
Oh, absolutely. That's a huge area. Their precision, their incredibly low rolling resistance makes them just indispensable there.
Yeah.
In semiconductor manufacturing, for instance, being off by just a tiny fraction of micron can ruin a whole batch, costing a fortune. So these bearings are critical.
Right.
They help cut down heat and wear, too, which is vital for keeping things accurate over long production runs.
It's not just the big industrial stuff, is it? The data we looked at also points to big growth in medical and lab equipment markets.
That's right.
Things like MRI machines, diagnostic tools, even surgical robots. They need movement that's not just precise, but also really quiet and vibration-free. That seems like a whole different challenge.
It really is. The demands there are incredibly high. Surgical robots, for example, need movements far steadier and more exact than a human hand could ever manage.
Wow.
And linear ball bearings, they're just a perfect fit for that. That's why they're becoming core components in that whole rapidly growing healthcare tech sector.
Okay, so these bearings sound amazing, almost like magic, indispensable. But like any high-precision tool, they must have downsides, right? Some Achilles heels. What did our deep dive uncover about the obstacles they face in the real world?
Well, yeah, despite all the good points, they do have a major vulnerability: contamination
Hmm.
and harsh environments. They really work best when things are clean and well lubricated. So without special seals or coatings, things like dust or corrosive stuff, even just strong vibrations can really mess with their performance.
Right.
That limits where you can use them, especially in really heavy duty or, exposed situations. It's a constant fight to keep them clean.
That makes total sense. And what about the cost? I mean, getting that kind of precision can't be cheap, surely.
You nailed it. That
Yeah.
brings up another key point. They are relatively expensive compared to simpler options like plain bearings or sleeve bearings,
Oh, okay.
because the manufacturing requires such tight tolerances and often premium materials, they just cost more. So in applications where cost is the absolute number one factor, if the loads aren't very high, sometimes manufacturers will go for the more budget-friendly alternatives.
And it's not just the purchase price. Right. What about, like, keeping them running? Maintenance?
Spot on. Maintenance and installation can be tricky if you don't align them perfectly, or if the lubrication isn't right, or even if they're just installed incorrectly, they can fail way sooner than they should.
Yeah.
Often you need skilled technicians for setup and regular checks. That adds to the total cost of ownership, which might make them less attractive for smaller companies or simpler machines.
Okay, so challenges exist.
Yeah.
But the industry isn't standing still, I assume. What are some of the interesting trends shaping things? Maybe even tackling some of those hurdles we just talked about?
Definitely. Looking at the bigger picture, there's a really significant shift towards maintenance-free and sealed linear ball bearings.
Ah, sealed units.
Exactly. These often have self-lubricating features, so they last much longer and need way less upkeep. That's a real game changer, especially for industries like food processing, pharma, or clean rooms, where contamination is a huge no-no and uptime is critical.
That sounds like it directly addresses the maintenance and contamination issues.
Nar.
What else is happening?
Another really big trend is integrating smart sensors right into the bearings themselves.
Oh, interesting. Like IoT for bearings.
Sort of, yeah. These systems can track things like the load they're under, the temperature, how far they've traveled. This allows for predictive maintenance.
So, fixing it before it breaks.
Precisely. Companies can anticipate problems, schedule maintenance proactively, and drastically cut down on unexpected downtime. It fits perfectly with those, Industry 4.0 goals.
Makes sense. And one last thing, as everything seems to be getting smaller, are these bearings shrinking too? I'm thinking about tiny robots, miniature medical devices.
You're absolutely right. There's a huge and rapidly growing demand for miniature linear motion bearings. As machines get more compact, robotics, consumer electronics, medical tools engineers need tiny bearings that still deliver high performance.
Wow.
They have to maintain that precision and handle the necessary load, but in incredibly tight spaces. We're talking down to just a few millimeters in some cases, but still providing flawless, reliable motion.
So, wrapping this up,
Yeah.
what does it all really mean? It just highlights how these precise, often hidden components are truly fundamental to so much of the advanced tech we use every day. They're the quiet foundation of our modern world.
Yeah, and it really brings up an important question for the future, I think. As technology keeps pushing towards, ever greater miniaturization and complexity, how is the industry going to make sure these critical precision parts stay cost effective? And how do they make them resilient enough for all these new, diverse, and demanding environments they're being put into?
That's a really great thought to leave folks with. Thanks for joining us on this deep dive. Keep exploring the fascinating world of technology and innovation.